right? Let's get into it. We'll just do the same thing that we kind of did at the end yesterday, which is like the real life applications. And this one, anyone can do this, right? Like this kind of, and they're all gonna be pretty straightforward. What happens is they're gonna give you like this question. They're gonna give you a perimeter, right? This 100
Mm-hmm.
is the perimeter. And then we want to form a rectangle, something like this. Let's say this is length, let's say this is W, and boom, 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 boom. And then we need to maximize the area. The area of this rectangle is what in terms of L and W?
L times W.
Yeah. What's the perimeter of the rectangle in terms of L and W? So this will be L, this will be W, right? Perimeter is just the sum of all sides.
2W plus 2L.
Yeah, 2W plus 2L. And we know that the perimeter is 100. So boom, 2W plus 2L. Like that, yeah?
Uh-huh.
Divide both sides by 2, or you can pull a 2 out here, like this. Equals to 100, so that means W plus L is 50. So that means W is 50 minus L. So this is the point. You start from here and get to this, write one variable in terms of the other, and then we're just going to plug it into this area equation. So we know W is going to be 50 minus L, so L times 50 minus L. If you open this bracket, what do you get? If you FOIL that,
50L minus L squared.
okay, 50L minus L squared. Now you have an equation for area, right? What type of an equation is that? 50L minus L squared. What could it look like? Ideas? That's just a quadratic, okay?
Mm-hmm.
It's a quadratic. So if you plug L as 0, you're gonna get A as 0, so it's gonna go through the origin, and it's a negative quadratic, so it's gonna open upside down like this. We're looking for this. How do we go about finding that? That's when the slope is 0, right?
Mm-hmm.
So we have the function, area function. Let's find the slope, which is just the derivative, okay?
Uh-huh.
So what's gonna be the derivative of this? 50L minus L squared.
50 minus 2L.
Yeah. So 50 minus 2L. And what do we know about the slope? What's gonna be the slope at that point?
0.
0, right? So we're gonna set this equal to 0, and then we simply solve for L. So you can subtract 50 from both sides. So this negative sign and this negative sign cancels out. So L must be 25, right? Like that. And then you plug L in here to find W. W is going to be 50 minus 25. W is also 25. So actually this is a square. So you end up getting a square that has 25 and 25. And that's always going to be the case. When you're trying to maximize the area, the figure that has the maximum area will be a square. Okay?
Okay.
So for example, if you have 200 meters or centimeters of something to work with, how do we turn this into a square? 200 means 50, 50, 50, 50, right? Like that. There you go.
Uh-huh.
So the dimensions that's going to give you a maximum area is going to be this one. You just divide that by a 4, I guess. If they give you 300, you divide that by a 4. It's not going to be a nice number, I don't think. It is a nice number. Actually, it's 75. So if they give you that, it's going to be 7. So that's a little shortcut that you can use. The maximum area is always going to be a square. All right, a similar question, but they've given us the diagram here. What is the perimeter of this diagram in terms of x and y? See, there's an x up here, there's an x up here, there's a y here, there's a y here, right?
Mm-hmm.
So if you add all of them up, what do you get?
4x and 3y.
Yeah, the perimeter is 4x plus 3y, right? And we know the fencing, the perimeter, we have 1,000 meters of fence to work with. So we're going to say that this perimeter is equals to 1,000. Now we can either solve for y or x here, it doesn't matter, but you need to write one variable in terms of the other. I'm going to solve for x. So 4x will be 1,000, right? Minus 3y. And then you want to divide both sides by 4 to get x. It's going to end up looking something like this. Yeah?
Uh-huh.
What's the area of this diagram in terms of x and y?
It's just y times x.
Oh, no, it's not. It's going to be,
Oh, y times 2x.
yeah, exactly. So 2x times y. We know what x is. X is 1,000 minus 3y divided by 4, like that, right?
Mm-hmm.
You can open the brackets. I guess 2 is gonna go into 4 twice. And then you can FOIL y in there. You get 1,000 y minus 3y squared all over 2. Yeah,
Uh-huh.
like that. And you can separate them if you want. So 1,000 over 2 is 500 y. Minus 3 over 2 is just 3 over 2 y squared. There you go. That's the area function. What do we want? We want to maximize the area. What do we do with this? Again, if you notice, it's a quadratic. Y minus y squared. It's gonna be a parabola that opens downwards. We're trying to find this. Again, the same thing that we did in the previous question. We need to find the turning point, or in other words, where the slope is 0, okay? Where
Mm-hmm.
the slope is 0. So to find that, we need to first find the slope function, which is just the derivative, which is just a prime. So if this is a, what's a prime?
The derivative.
Yeah, so what would that be? If you find it, what's the derivative of this? Um, 500y?
500 minus 6 over 2.
Mm-hmm. So 6 over 2 is just a 3y, right? Like that.
Uh-huh.
And then what do we do with this? This is the derivative. We know this has to be 0 at the maximum because there's going to be a turning point there. The slope of the tangent is 0. So 0 equals 500 minus 3y, and then we can solve for what y is. It's just going to be 500 divided by 3. So y is 166.67 meters, okay?
Mm-hmm.
And then plug it back in here as y. So to find what x is, so times 3,000 minus that divided by 4. That's going to give x as 125 meters. So there you go. X is 125, and then y is 166.67, and that will give you the maximum area of this. Cool?
Mm-hmm.
What about a different diagram? The cylinder one is looking spicy, I guess. So we need something, a cylinder, to have a volume of 1,000 centimeters cubed. Determine the dimensions that require the minimum amount of tin for the can. All right, so I don't know, this is gonna test your cylinder knowledge. What is the volume of a cylinder? What is a cylinder? It looks something like this, right?
The area of like the circle times the length.
Yeah, it's pi r squared h. Okay,
Mm-hmm.
so that's gonna be the volume. Um, and we know this needs to be 1,000, right? 1,000 equals pi r squared h. Uh, what else do we know? What if we, I don't know how to explain this. What we're gonna do is we're gonna cut this cylinder like this, okay?
Uh-huh.
And then just flatten it out like this. It's gonna look something like that. You can imagine if you cut something and spread it out, it's gonna turn into a rectangle. Yeah?
Mm-hmm.
Um, the height of the cylinder is gonna be the height of the rectangle. But now this component though up here is it's gonna be what? That one's tricky. This component up top is gonna be the circumference of the circle. You see the circle?
Mm-hmm.
What it did was we took it and we stretched it out, flattened it out. So if that's the radius, this line is gonna be the circumference. What's the formula for a circumference of a circle?
2 pi r.
Yeah, exactly. 2 pi r. Um, so what can we do? What's the question asking us? It's asking us for the dimension. So we need to find r and h, right?
Mm-hmm.
Hmm, what do you think? We basically need to write one thing in terms of the other, okay? Oh, actually, yeah, no, this isn't that bad. What's the perimeter? It's the same kind of question as before, but instead of area, it's a volume question. What's the perimeter of this rectangle?
4 pi r plus 2h.
That's perfect, yeah, plus 2h. Now, instead of subbing the perimeter into the volume, we don't know what the perimeter is, right? But we do know what the volume is, you see, like this. So we need to solve for either r or h from here and then sub it into the perimeter, find the first derivative, and we're done. So let's solve for h here. What do we get if we want to isolate the h on the right side?
Um, 100 minus pi times r squared.
Some minus. It's going to be 1,000 over pi r squared. Divide both sides by pi r squared.
Okay.
And then we're going to take this h, right? And I'm going to plug it in here. So we're going to get 4 pi r plus 2 times 1,000, 2,000 over pi r squared, like that. Cool?
Mm-hmm.
Now we need to find the derivative of this. We need to find where the slope is 0, because that's where the turning point will be. What's the derivative of 4 pi r? It's just like saying 20x, the constant. The x drops and you're left with the constant. Same thing here. R is like our x. The derivative of 4 pi r is simply 4 pi, because 4 pi is a constant, right?
Mm-hmm.
The other one's a little bit tricky. What we can do is we can rewrite that as 2,000 over pi, because this is a constant, but our variable, we can toss it upstairs like that. What will be the derivative of this? So the -2 is going to come in the front, right? So you have minus 2000 times 2 is 4000 over pi, and r to the power of what?
-3.
Yeah, -3. And we know that the derivative is going to be 0, because that's where the turning point is. So boom, equals 0. Now let's solve for r. I guess the r to the -3, I can just toss it in the denominator like this to make it nicer, like that. Now the question is, how do we solve for r? Any ideas? We can definitely solve it. Step 1, subtract 4 pi from both sides. So you get 4 pi, -4 pi is equals to -4000, but the negatives, they cancel out. So you get 4 pi is equals to 4000 over pi r cubed, yeah? Now what? What can we do on both sides to solve for r? Notice how r, the unknown, is in the denominator. What do we do when the unknown is in the denominator?
You multiply.
Yeah, you multiply both sides by that unknown. So times r cubed here times r cubed here, like that. This disappears, right? So we have something like this. Now what do? We're trying to solve for r.
Multiply by pi.
So we need to get rid of 4 pi here, right? So you divide both sides by 4 pi. That'll give you something. So it's gonna be 4000, and then divide both sides, it's gonna end up here. You get over 4 pi squared, yeah? And then 4000 and 4, they cancel out. You get r cubed is 1000 over pi squared. Now what? We're trying to solve for r. Right now we have r cubed.
You cube root both sides.
Yeah, you could cube root both sides. So that's going to cancel out, and that's going to give you a nice number. So cube root of 1000 divided, it's not going to be a nice number because there's a pi, but it'll give you something. The radius has to be 4.66 cm. There you go. And then you can plug this over here to find what r is. So 1000 divided by pi times 4.66 squared. And that gives you h as 14.64 centimeters. Cool? And that's it for part A. That's going to be the dimensions of the cylinder. Part B's write it as a ratio of height to diameter. So height is 14.64. If this is the radius, how do we find the diameter? We just times it by 2,
Just
right?
times it by 2.
Yeah, 4.66 times 2. So this divided by 4.66 times 2, you get a ratio of 1.57. Yeah? What about this? What's the ratio of over here? Height is 4, the diameter is 6, right? This is 2 over 3, this is 0.66. And it says the smallest can. So our can is definitely bigger than this, but that's fine, right? So yeah, the answer to this, does this ratio meet the requirements? Yes, it does, because minimum it has to be 0.66. This is not the ceiling, this is the floor, basically. This is the smallest number. 1.57 is definitely bigger than this. So yes, it does meet the requirement, and we're done. Okay. So there you go. Sometimes you can use it in like a volume kind of a question, and you can imagine what, like this is being something like this is being done in every like factory, right? Because cylinder is cans. A lot of canned foods come in cylindrical form. So to save costs, this math is definitely being done somewhere. Let's try another one. Determine the area of the largest rectangle that can be inscribed in a right triangle. Inscribed just means it's gonna fit inside, okay? So a right triangle would be something like this. It's a triangle that has a right angle here. If the legs adjacent to the right angle are 5 and 12, okay?
Mm-hmm.
It says the two sides of the rectangle lie along the legs. So what does that mean? I think it means something like this. Like that. So this is gonna be our rectangle here. And we need to maximize the area of that rectangle. Make sense?
Mm-hmm.
So how do we do that? Any ideas whatsoever? Where to even start with this one? Well, it's gonna be a perimeter area question, basically. That's a hint. Let this be x. X is from here to here. And let's this be y. Y is the width of the rectangle, right? Like that.
Mm-hmm.
Um, so what will be the perimeter of that rectangle?
2x plus 2y.
Yeah, 2x plus 2y. The area will be what?
Y times x.
Yeah, y times x. This is what we're trying to maximize, but we don't have the perimeter, do we? I don't see a perimeter. What about actually now we have another triangle up here, right?
Mm-hmm.
We have another triangle down there. Does that help us? We definitely need to know what the perimeter is of this rectangle in order to solve this. If that is x, then this thing up here will be what? 12 minus x, right?
Mm-hmm.
This thing down here will be 5 minus y. What about this part, the hypotenuse? How do we find the hypotenuse of a right angled triangle? Any ideas?
You square the other numbers and add
Yeah,
them.
just go with the other numbers and you add them. So the hypotenuse C is gonna be 12 squared plus 5 squared, like that. That's gonna give you 169, which is 13. So we know the hypotenuse is 13, yeah, like this.
Mm-hmm.
And that's the trick to this question. The perimeter, not the perimeter, but the sum of x and y, when you add this side and this side, you're gonna get the hypotenuse. Okay? X
Uh-huh.
plus y is going to be 13. There we go. And this is going to give us an equation. X will be 13 minus y. Plug that in here. 13 minus y times y. That'll give you 13y minus y squared. That's just a, right? What's going to be a prime?
13 minus 2y.
Yeah, 13 minus 2y. And then again, we set this equal to 0. Set the first derivative equal to 0 for any min-max questions. So 2y will be 13, y will be 13 over 2, and there we go. Plug that back in here, you'll get x. Cool?
Uh-huh.
As you can see, b and c is the same thing. Um, how do you feel about this?
It's okay.
let me see what else we can do. Let's try doing this guy here. A lot of words here, but it's not really that relevant. See, the y value c of x is the cost, and x is the liters, okay?
Mm-hmm.
Part A, again, it says the average cost of producing 625. It's not asking us to find the rate of change or anything like that, right?
No.
Okay, so how do we do part A?
You just plug in 625 as x.
Yeah, that's all you have to do. So you just find C of 625. That's going to be 75 times 625 minus 10. I think the square root of 625 is 25. So square root of 625 minus 10. That'll give you 1125. What's the unit for part A? It's asking you to find the average cost.
So dollars?
Yeah, dollars. That's it. B is asking you to find the marginal cost, which is just C prime of x, just the first derivative. And then you plug this in there, okay? To find whatever that is. So if that's C of x, how do we go about finding C prime of x? And I'm going to
What
give
does
you
marginal mean?
rate of change.
Okay.
Marginal cost means the rate of change of the cost function. So basically we need to find the derivative of this. It means this. This is gonna be the answer. This is gonna be the answer to the question I was gonna ask you later. So C of x, you have dollars here, right?
Mm-hmm.
On the y-axis, and on the x-axis you have liters. Marginal cost is how much dollar are you getting per liter, right?
Mm-hmm.
They're always trying to increase this. They're always trying to maximize this, I guess. Actually, this is the cost. This is not the revenue. So would they be trying to maximize this or minimize this?
Minimize.
Minimize, exactly. They want to maximize the revenue, marginal revenue, but not the marginal cost. They want to minimize this as much as possible. Because if they minimize the cost, they will maximize their profit, right? So when you find C prime of x, they've given us C of x. The trick is to open this bracket. Alrighty, now a question for you. How do you find C prime of x? What'll that be here? It's not a nice quadratic that you can just bring the numbers down. Square root of x, if you write this in exponential form, what is that? What does that equal to? If you write this in
To the
power,
power of 1/2.
yeah, and that's what we should be doing, to the power of 1/2. Now this makes our life easier. The derivative of 750 is nada, so this just disappears. What's going to be the derivative of this guy?
75/2x to the power of -1/2.
Yeah, so 75 times 1/2, x to the -1/2. Yeah?
Mm-hmm.
And then they want the marginal cost when the liter is 1225. Liter is the x value. So we need to find C prime of 1225 like that. This is just the square root, right? If you throw it downstairs, it becomes positive, and it's just the square root. Square root of 1225 like that. So 75 divided by 2 times square root of 1225. And that gives us 1.04. What's the unit? It's dollars per liter, right? It's just the slope.
Mm-hmm.
Rise over run. Rise is the y dollars, run is the liters in this case. Cool. C, how much production is needed to achieve a marginal cost of 0.50 per liter? How do we do C? So now what they've given us is they've given us C of X, which is 0.50, right?
Uh-huh.
And they're asking us to find how many liters should you be producing to achieve this marginal cost. So you need to solve for X using this function here. You need to solve for X. The unknown is in the denominator. What do we do?
You multiply.
Yeah, you're going to multiply both sides by that unknown. So you get 0.50 times root x, and 75 over 2 is just 37.5. What's next? We're trying to solve for x.
You divide by 0.5.
Yeah, divide by 0.5 is the exact same thing as multiplying by 2. So 75. What's next? We have root x. We need x.
You square both sides.
Yes, you square both sides. So 75 squared is the answer. 75 squared. That gives x is 5625 liters. And you're done. Okay, that's a lot of liters. But at that liter, the cost is pretty low, 0.5. What if they're like super cheap? What if they want 1 cent? Let's say the marginal cost is gonna be 1 cent, right? Let's see how much they need to produce. 1 cent is 0.01, yeah?
Mm-hmm.
So x will be 75 over 2 times 0.01 squared. That's just for curiosity. Let's see if that's even feasible. 0.01 squared. Oh my God, it's 187,000 liters. That's a lot of liters, right?
Mm-hmm.
Yeah. I don't know if that's possible, physically possible. And it's, what is it? Maple syrup. Yeah, that's a lot of liters. And if one factory can do that. So this is not really feasible. 1 cent. All right, they've given us something. They've given us L of t. We need to find L prime of t, right? How do you
Mm-hmm.
find the derivative of this function? What's the rule that we need to use?
The quotient rule.
Yeah, you remember what it is? So the numerator is f, denominator is g. It's f prime g minus f g prime all over g squared, like that.
Mm-hmm.
So what's f prime?
6.
Yeah, 6 times t squared plus 2t plus 1 minus 6t. What's the derivative of the denominator?
2t plus 2.
Yeah, 2t plus 2 all over that denominator squared. So that entire thing squared. And then they want to find the value of t when this is equals to 0, like that. Yeah?
Mm-hmm.
To solve for this, multiply both sides by the denominator. It cancels out because 0 times that is just 0, right?
Uh-huh.
So denominator is gone. Let's open the bracket. We're going to get a quadratic. Hopefully we can man this. So you get 6t squared plus 12t plus 1 minus 12t squared minus 12t, like that, right? So plus 12t and minus 12t is gone. 6t squared minus 12t squared is minus 6t squared.
Wasn't the plus 1 supposed to be 6?
You're right, it is. Plus 1 is 6. 12t is gone. 6t squared minus this is this. Plus 6 equals 0. How do you solve this for t? It's
You
not,
subtract 6.
yeah, you subtract 6, so negative 6 t squared is negative 6. The negative signs cancel out. Divide both sides by 6. You got 1, right? So t is plus minus 1. Does it make sense for t to be negative? Look at what t is. T is
It's
time.
time.
Yeah, so it doesn't make sense for it to be negative. So t must be 1, right? There we
Mm-hmm.
go. And it says determine LT for the value found in part A. So to do part B, you just plug 1. You just find L of 1. That'll be 6 over 1 plus 2 plus 1. That's 6 over 4, 1.5. Cool.
Uh-huh.
The next part says graph this. We can really quickly graph and see what's going on here. 6x squared plus 2x plus 1. And again, ignore the negative quadrants, right? Let's see here. What is happening to the slope? By that I mean we're looking at the tangent, okay? So check this out. Initially the slope is very high, right? Look at that. It's very high. It's
Mm-hmm.
almost vertical. Then it becomes almost 0, right? It's not really a
Uh-huh.
complete turning point though. If it was a complete turning point, it would be 0. That's not a complete turning point. And then what's happening? It's becoming negative, 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 and eventually it's approaching 0, yeah?
Mm-hmm.
So to answer this question, what is happening from 2 to 8? Where's 2? 2 is here, so it's look like this. 8 is here, it looks like this, so it's decreasing. The slope is approaching 0, and that's going to be the answer. Cool?
Uh-huh.
It's stabilizing, I guess. That'll be another way of putting it. Does it ever hit 0? No, it never hits 0. It just keeps going and going. So it's approaching 0, and that'd be the answer to that. And that is also the last question for today.